Desalination is a critical solution for addressing global water scarcity, but its implementation often involves high capital and operational costs. Operational costs in water treatment are often driven by energy consumption and frequent maintenance, especially when filtration systems fail to operate efficiently. Unfortunately, filtration is frequently treated as a secondary consideration, despite its direct influence on the performance and longevity of desalination systems. Optimizing filtration design, particularly through the use of advanced filter media, can significantly reduce these costs. Among the available options, woven wire mesh filters stand out for their ability to deliver high flow rates with minimal pressure loss, superior backwashability, and long-term durability. These characteristics make them ideal for pre-treatment stages in desalination, where consistent and efficient filtration is essential. Desalination systems rely on a series of complex processes to convert saline water into potable water. Among the most widely adopted methods are reverse osmosis, multi-stage flash evaporation, multi-stage distillation, and mechanical vapor compression. While thermal processes like multi-stage flash evaporation, multi-stage distillation, and mechanical vapor compression may not require extensive pre-treatment, membrane-based systems like reverse osmosis are highly dependent on effective filtration to prevent fouling, maintain energy efficiency, and ensure long-term reliability. As reverse osmosis continues to dominate modern desalination, filtration design has become a critical factor in operational performance and cost control. Seawater presents a uniquely harsh environment for filtration systems. High salt concentration, suspended solids, biological contaminants, and fluctuating feedwater conditions place significant mechanical and chemical stress on filter elements. These challenges are compounded by the need for consistent performance over long operational cycles. Traditional filtration media often fall short under these conditions, leading to frequent replacements, increased maintenance, and compromised system reliability. The effectiveness of filtration systems is governed by several design parameters, including pore size distribution, flow rate, pressure drop, and material compatibility. Systems that fail to optimize these variables often experience reduced throughput and higher operational costs. For example, filters with inconsistent pore structure may allow fine particles to pass through, increasing the load on downstream membranes, which are extremely costly to replace, making efficient pre-filtration essential. Similarly, materials that degrade under saline conditions can introduce contaminants and require premature replacement. To meet the demands of modern desalination, filtration systems must be engineered for performance and durability, designing structures that withstand mechanical loads and implementing configurations that support high dirt holding capacity without sacrificing flow uniformity. These requirements have led to the development of advanced solutions like sintered mesh laminates, which are technically and economically superior alternatives to conventional media. Traditional filtration media used in desalination pretreatment, such as sand, cartridge, and depth filters, have long been the industry standard due to their availability and low upfront cost. However, these systems often fall short in high demand environments. Sand filters require frequent backwashing and struggle with fine particulate removal. Cartridge filters offer solid precision but are single use, leading to high replacement costs and waste. Depth filters, while effective in layered filtration, are prone to clogging and difficult to clean, resulting in increased maintenance and downtime. Woven wire mesh filters, especially when engineered into multi-layer filter elements, offer a more refined and sustainable solution. Their uniform pore structure enables precise particle retention, which is critical for protecting expensive downstream reverse osmosis membranes. Unlike disposable filters, woven wire mesh can be cleaned and reused multiple times without compromising performance. This reusability not only reduces material waste, but also lowers long-term operational costs. Additionally, the open area and permeability of mesh structures support high flow rates with minimal pressure drop, improving system efficiency. One of the key differentiators of advanced woven wire mesh, especially sintered mesh laminates, is their mechanical and chemical resilience. These laminates are composed of multiple mesh layers that are metallurgically bonded, resulting in approximately 25% higher burst pressure resistance compared to non-sintered filter elements and eliminating the need for additional support structures. When manufactured using seawater-resistant alloys like Vista 254 SMO, these filters achieve exceptional corrosion resistance with a Pren value of 43. This makes them ideal for long-term use in saline environments, where conventional materials often degrade rapidly. So from an economic standpoint, woven wire mesh filters offer a compelling value proposition. Their durability and cleanability reduce replacement frequency and labor costs, while their structural integrity enhances operational safety. The combination of surface and depth filtration in sintered laminates allows for high dirt holding capacity and uniform flow, reducing the need for secondary filtration stages. And for desalination plant operators, these benefits translate into lower life cycle costs, improved system reliability, and a more sustainable filtration strategy, all of which support a long-term ROI. Designing a desalination system that balances performance and cost efficiency requires careful consideration of every every component. Pretreatment systems must be engineered to handle high volumes of saline water while maintaining consistent output quality. Woven wire mesh filters, when integrated early into the design phase, offers a scalable solution that supports high throughput, minimizes pressure loss, and reduces the burden on downstream processes like reverse osmosis. One of the key advantages of woven wire mesh is its adaptability. Mesh filters can be customized by adjusting mesh count, wire diameter, and layer configuration to meet specific feed water conditions and system requirements. So in desalination applications, this means tailoring the filtration precision to reduce SDI and turbidity levels, which directly impacts membrane longevity and energy efficiency. The ability to engineer mesh laminates like Porostar with precise specific layers such as the filter, protective, and support layers allows for optimized performance across a wide range of operating conditions. Material selection plays a critical role in the viability of filtration systems when exposed to seawater. Alloys like Vista 254 SMO, with the ability to be used in sintered mesh laminates, offer exceptional resistance to corrosion, mechanical stress, and chloride-induced degradation. These properties are essential for maintaining filter integrity in high salinity environments. And the sintering process further enhances mechanical stability, eliminating the need for additional support structures and enabling reliable, series-ready production of seawater-resistant filter elements. So integrating woven wire mesh into desalination system design yields measurable operational and financial benefits. The durability and cleanability of mesh filters reduce maintenance frequency and labor costs, while their high dirt holding capacity and uniform flow characteristics improve overall system reliability. By minimizing the need for secondary filtration stages and reducing downtime, plant operators can achieve a lower cost of ownership and a faster return on investment. These advantages position woven wire mesh as a strategic asset in the design of modern, cost-effective desalination infrastructure. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things WS Tyler. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.